All right, so I'm taking us through our principles of Autodump Design today. So the program we are using today is Studio OP. It exists within the planning suite of Datamine softwares. We also have additional production, laboratory, and sustainability softwares should you require any additional software packages in your day-to-day work. So what we will be covering in this particular webinar is the dump design setup, including the required geotechnical design parameters, initial dump design complete with ramp, and a dump design verification, including the total volume of the dump. So I'll be taking us straight into our demo. Okay, so as you can see, I have just quickly set up a very um, loose version of Studio OP. So we basically have nothing in this particular setup except for our topography. So I will be starting a setup from scratch and it will be a dump design setup. So the first thing we need to do for a dump design is we need to add the topography and we also need to generate a couple of lifts. So in this case, I will be starting from 2150 and I will be doing lift heights of 3.3 and I want about 50 lifts. So I just want to give myself enough room to work with when I am designing my particular dump design. So I simply say OK, and I will save and close this task. Before I design the slopes, I'm actually just going to switch back over to the 3D window and I'm going to generate quickly some slope regions. So I'll have a quick look at our topography and I'll say, for this particular dump design, we don't so much have constraints, rather we have an area that we would like to infill. So I'm going to create a new points file using our current objects toolbar. And I'm just going to quickly add a point while snapping to the surface. So command, I use that as hotkey, NPO. So that'll just give me a quick point. And I'll just turn off my wireframe for a second. I'll also generate a new strings file. I'm just going to create a couple of regions. It's not specifically required for this particular setup, but it's a good start just to generate a couple of quick regions in case you need them. So I'm just generating a couple of strings. So I'm just also going to add a slope region column. So I want this region column to be alphanumeric. I want it to have a character length of 16 and I want the default value to be absent. So I'll just say OK, and I will bring up my data properties. As I have this top region highlighted, we'll call this region North. That one can be East. This one can be South. And West. So I just have a couple of regions in case I want to do anything region specific. I'm just going to save these strings. So once you've saved your strings, you can jump back into design and start defining your slopes. So for this one, I'm going to select some boundary strings. I'm going to select that string file that I just created. And it gives you automatically your east, north, south, and west values. However, for this particular design, what we're really interested in is our 3.3 meter lifts to create approximately a 10-meter bench. So I'll quickly show you how to, in the same way I demonstrated constraints in the last webinar that I completed, I'm actually going to demonstrate how to double lift and triple lift just to create appropriate bench heights. So I want a berm width of 17 for all of them. So inter-ramp angle of 10. And I want, just say if we tried 45, I'm actually searching for an IR angle of 17. So it gives me with a inter-ramp angle of, sorry, with a face angle of 45 and a lift height of 10, it's giving me an IR angle of 20.3, which is a little bit high, so I'll try 32. That's more appropriate. So we are also going to use lift overrides to triple lift. So I'm going to say for every 3 benches, set 2 benches to none. So I don't want any of these benches to have associated berms. So you can do this technique both in Autodump Design and Auto Pit Design. It's just labeled slightly different. In Auto Pit Design, it's called a bench override, and in Autodump Design, it's called a lift override. So I'm happy with that, and I will go save and close. All right, now I will bring us straight into our auto design setup. You can see we have the topography if we tick show topography, and we also have the slope regions if we tick show slope regions. So they're coming up nicely. So what we need to do now is to have a quick look at our topography. We aren't really constrained so much by features on the ground here. What we are constrained with dump design is basically developing a final form for your dump design that merges nicely into local topography. So we don't want any sharp angles. We want something that is effectively easy to rehabilitate. So it doesn't have any steep walls, and it has really nice curves, giving it a nice form factor for aesthetic reasons. So we also want to maximize the topography to essentially get some extra area in which we can infill a dump. So I'm just going to say I would like a new string file, and I am just going to generate the base constraint string for this particular dump. Okay, so we now have a string, and I'm just going to quickly save this. as our base constraint string. I'm just going to quickly pull up our task window. Okay, so when you jump into Autodump Design, you will get this task window up, and it's basically telling you how you want to generate your dump. In this case, we've got a bottom-up design because we're using a base constraint string. So I'll just add that string to constraints pretty quickly, and I'll turn off that particular string. So it will generate from this particular base string, provided you just hit recalculate. So I'm just going to mark design strings below topo and create a surface intersect. So I'm going to go recalculate. And it has given us a quick dump design based on the parameters we specified. As you can see, and I will quickly make a design surface just to show you this a little bit easier. It has given us 3.3 meter lifts. So every single with no berms in between. So yeah, every single lift is actually a mini part essentially of an overall lift. So why we want 3.3 meter lifts is that so when we're tipping out this material, because dump design is generally made from tipped material, we can then doze over the top of it and compress it in order to make our structure more stable. So that's why we're doing it in little 3.3 meter lifts. It's basically because that's close to the height of a full truckload of material when it dumps. And once you go over the top of it with the dozer. Okay, so what we really want to do now is we have a little bit of a dump design, but it's not really in a format that I would think is acceptable. So give me a second. I'm just going to turn off my wireframes and my solids. So what I'm actually chasing, if I just show my strings, is I want 3 meters up or a height, sorry, 3 lifts up. So I want to select this one and I will delete this base string. And I'm also going to smooth this one. So I'm going to go SPF just to smooth out these strings. Radius of 30. So when I hit recalculate, and I think I'll go top down as well, it gives us a nice, smooth, rounded area that we can use to design our dumps. So what I'm trying to do here is I want to generate, first of all, my final form. So that means basically pulling out a wireframe from this particular design. So I will select that string and that string. And I'm just going to save both these strings as my final form strings. So I'm just going to wireframe up this particular object. So I want it in plan view. I want it inside boundary strings. The command I used then was MD, which if you check your surfaces, and you go to DTMs, you can just hit this main button here, and it will make your DTM for you. So, or you can just type the hotkey, which is MD, when you've selected your strings. So I'm actually using the 3D window to select which strings I actually want to wireframe up. So I'll just go next, and I want this one to be my boundary string. I want everything within this particular boundary string. And it's given me a cute little wireframe of this particular pit. I also want to create a final form solid just so that I can estimate the volume of the material within this particular solid. So to do that, I will go DTMs, solid under DTM. Okay. It's put it in my IO Northstop GDP. So I am just going to actually create a new wireframe and try that one again. So just be aware which one is your current object. Or even select a new object. So I'll just say final form wireframe is also the alternative option. So points and strings, I want that one and that one. And just this boundary. There we go. Okay, cool. So now I have my final form wireframe and my north stock, my topography. So solid under DTM. And I want a new solid, which will be my final form solid. Okay, cool. So I'll just pull those ones off. And I've now got a full solid that I can now use to generate a volume. So I want to output this to table. I want to call it final form volume. And I want to go OK. So as you can see, we've got an enclosed volume of about 13 million meters cubed. So I'm going to go OK. And I am quickly going to go into loaded data and save this. So all the data that you're generating for this particular project, you should be able to find in your loaded data. So you can save it as a .dmx, and I'm also going to save it as an Excel file, just so I can do a quick comparison in Excel. So as you can see, we now have a volume in Excel. In fact, I'm going to that we are now trying to match. Okay, so now that we've got our final form and we're happy with it, it's got nice smooth curves, it's working well. If you would like to, you can have another quick look at the design strings, and you can actually just quickly check the gradient. That's a pretty common check that I do when I'm looking at these particular designs, just to make sure that it is precisely what we're chasing. So I might quickly do a new string, and I will do it from this particular point. And we'll go down to here. And as you can see, we were aiming for about 16.9 and we've got about 16.77, which is pretty close. Very, very close. It's just under the 17-degree slope angle that we were aiming for, so going well. Okay, so now that we've got a final form design, what we actually need is our tip 2 design. So I'm just going to turn this off, bring back my topography, and show my dump constraints. So I'm going to bring back in my base constraint string, and I'm going to offset this by about a bit over half the berm width. So our berms are about 17 meters from memory, and I'm probably going to try at about 10 meters. So I'm just going to offset this quickly just to develop my tip 2 lines. Okay, so we've just expanded this particular string ever so slightly. Just turn off the wireframe just so you can see it fully. So there's the original, there's the new one. So I'm just going to save this new string as expansion base constraint. And I'm going to quickly delete this one because I think I'm operating in new strings. So I'm just going to quickly delete this one and I'm going to reassign my base constraint, my expanded base constraint as the new design base. And then I'm just going to go recalculate, and it's pretty much repeating the same procedure. Sorry, I want a bottom-up design. Repeating the same procedure, but with a slightly larger pit base. So 1, 2, 3. So it should be this one. So I've switched over to a top-down design now, and I also want to just quickly smooth this because I do want really smooth tip lines, and I'm going to go recalculate. And now we do have a slightly larger set of design strings for our tip lines. So I'm just going to quickly create a new set of strings, and I'm going to say I want to copy data from, and I want to copy it from the D1 design strings. So that'll put all my design strings in new strings 2, and I'm just going to save this as my tip 2 design. Okay. So I'm also going to make a designed surface, just have a quick look at it. And now is a good time to compare the surfaces of both your designs, your final form, and your tip 2 designs. They should be very, very close, provided we haven't made it too small or too large. Final form wireframe. Okay, so I'm going to do a quick comparison of the tip 2 to the final form, and I'm going to say I'm just going to go from here through to here. I'm going to change my section so it's now vertical. And I'm going to make it a little bit wider so we can properly do a correct comparison. I'm also going to align my view with my section, and I'm going to have a quick look. So as you can see, for this particular example, might make it a little bit wider and alter it, shift it slightly just so we can see the green. We do have a line running through both of these designs, and this is a little bit of an iterative process. Possibly I wouldn't go 10 meters going forward. I might go 8.5, which is 50%. But as you can see, basically this little triangle here should be dozed into this triangle here. This triangle here should be dozed into this one. And this triangle should probably be dozed into this one. So basically you're trying to do your tip 2 so that it's almost 50% up here, can be dozed perfectly into here. So yeah, I might shrink this one a little bit if I were to do it as an iterative process, but it's pretty simple. You just expand it instead of 10 meters, you expand it to say 8.5, and then you basically just quickly recalculate. So I'm just going to say none and Shift Z. So I might clean this up a little bit, see how we're going for time. And final form, wireframe. You can also check it by checking the tons in both of your designs. So I'm going to do a quick comparison of the tons I have in both of my designs, or volumetric area, sorry. Just to see how close they are. So for one, we've got 13,373 and the other we've got 13,654. So yeah, if I were going to quickly do this one again, I would probably expand the lower design, the tip 2 design ever so slightly, just so that it comes out a little bit further and it better matches my volumetric design. So yeah, I would do this in an iterative process and probably go through one more iteration. Possibly instead of 10 meters, I would possibly choose, say, 12, just to get my numbers slightly closer. I believe they are. There's about a 2% difference there. So they are pretty close, but yeah, I would go for one more iteration and just try to bump the tons and the volume in this one a little bit higher, just so it better matches this one.